We're going to be finding the limit of an average rate of change. Here is your formula. It's basically a slope formula. It's basically like y sub 2 minus y sub 1 over x of 2 minus x of 1. And we're going to find the limit. It's read as find the limit as x approaches c, some constant, of the average rate of change of a function from c to x. You should have done a little bit of this already in pre-calculus. And we're going to get started with some problems. So the first one we have is f of x equals x squared, and we want to find what happens from c to x. C to x, and our c is going to be 2x. So what you do is our average rate of change, delta y. This is delta, means change in y over change in x. This is the delta sign. Okay, equals f of x minus f of 2 over x minus 2. Okay, this is going to be f of x. I just copied down f of x, which is x squared plus 3x. And I plug in 2 here. So 2 squared is 4, plus 6 is 10. So you get plus 10 over x minus 2. Okay, now I'm going to factor this. We get x plus 5, x minus 2, and divide it by x minus 2. This cancels, so when you find the limit, as x approaches our constant 2 of f of x minus f of 2 over x minus 2 equals the limit. I'm going to kind of skip here. X approaches 2 of x plus 5, and that equals 7. You just plug in the 2 here. Okay? Okay, the next one we have, c is going to be 2. Okay, c equals 2, and f of x equals 5x minus 3. So what we're going to do is take the limit. We take the limit as x approaches of f of x minus f of 2 over x minus 2, which equals the limit as x approaches 2 of 5x minus 3, and then plug in the 2 here. Plug in your 2, and you're going to get minus 7 over x minus 2, which equals, I'm going to scoot it over here a little bit, equals limit as x approaches 2 of 5x minus 10 over x minus 2 equals the limit as x approaches 2 of 5 times x minus 2 over x minus 2. These two cancel, so the limit as x approaches, you're using the constant property of 5 equals 2, because there's no x left. The next one, we have the limit as x approaches negative 2 of f of x minus f of negative 2 over x minus a negative 2. And that's going to equal the limit as x approaches negative 2 of 4x minus 3x, no, 4 minus 3x, and then you plug in the negative 2, and we're going to get minus 10 all over x plus 2, which equals the limit as x approaches negative 2 of negative 3x minus 6 over x plus 2, which equals the limit as x approaches negative 2 of negative factor out the 3, the greatest common factor, the highest common factor. And it's like the previous problem, which equals the limit as x approaches negative 2 of negative 3 is going to equal negative 3. And that's your answer. Okay, the next one is c is 3, f of x is x squared. So we're going to do the limit as x approaches 3 of f of x minus f of 3 over x minus 3. So you're just writing down f of x first, x squared, and then you're going to square the 3, so that's going to be minus 9 over x minus 3. And I should have done the limit here, so let me erase this real quick. So basically, it's the limit as x approaches 3 of x squared minus 9 over x minus 3, which equals the limit as x approaches 3. And I'm going to factor with the difference of the squares, x minus 3 times x plus 3 over x minus 3. These two cancel, so we get equals the limit as x approaches 3 of x plus 3, and this is going to equal, you plug in 3 here and you're going to get 6. Okay, so that's your answer. The next one, the same thing, we're just doing a lot of problems. We're going to take the limit as x approaches c, which in this case is 3, of f of x minus f of 3 over x minus 3, which equals x cubed. Now we're going to cube the 3, and that's going to be 27 over x minus 3. Now we're going to use our formula, a cubed minus b cubed formula, which equals a minus b times a squared plus ab plus b squared. And my a is going to be x, and my b is going to be 3. So I get x minus 3 times x squared plus 3x plus 9 over x minus 3. Okay, in this case, I'm going to do this in a different color. My a was x, and my b was 3. And I just plugged it in this formula. And that's supposed to be the limit, too. The limit as x approaches 3. And then we're going to cancel these two, and then you just plug in the 3. So we get the limit as x approaches 3. And you're just plugging in 3 here, 3 squared, plus 3 times 3, plus 9, and that's going to all equal 27. Okay, the next one is our constant is negative 1, so the limit as x approaches negative 1 of f of x minus f of c. Oh, our c is what? Negative 1, so let's plug in negative 1 over x minus a negative 1. Okay, and that's going to give us the limit as x approaches negative 1, and I'm just going to plug in my x. So this is x squared plus 2x minus negative 1, because when you plug in your negative 1, that gives you that over x plus 2 x plus 1, sorry. And then you get equals the limit of x approaches, as x approaches negative 1, x squared plus 2x plus 1 over x plus 1. I'm going to factor the numerator, the limit as x approaches negative 1. That's going to be x plus 1 squared, or I'll just write it out twice, over x plus 1. These are going to cancel, and then when you take the limit, you get the limit as x approaches negative 1, and plug in negative 1 to x plus 1, and that's going to equal 0. Okay, the next one is this one, and I'm going to go a little quicker now. Limit as x approaches negative 1 of f of x minus f of negative 1 over x plus minus a negative 1, which equals the limit as x approaches negative 1 of 2x squared minus 3x minus 5 over x plus 1. I'm going to factor the numerator, and this is going to factor out as 2x minus 5 times x plus 1 over x plus 1. These two cancel, so we're back to the limit as x approaches negative 1 of 2x minus 5. Plug in the negative 1 here. I'm just going to do it here. So the limit as x approaches negative 1 equals negative 7. Okay, the next one is the limit as x approaches 0 of f of x minus f of 0 over x minus 0 equals the limit as x approaches 0 of 3x cubed minus 2x squared plus 4 minus 4 all over x. Okay, this is going to equal the limit as x approaches 0 of 3x cubed minus 2x squared over x, which equals the limit as x approaches 0. I'm going to factor out x squared. I'll just factor out an x here because I want to get rid of this x here. So factor out an x. We get 3x squared minus 2x over x. The x's cancel, and to save time, when you plug in this 0 here, you're still going to get 0, so the limit is 0. Okay, the next one, the limit as x approaches 0 of f of x minus f of 0 over x minus 0 equals the limit as x approaches 0 of 4x cubed minus 5x plus 8 minus 8 over x, which gives us the limit as x approaches 0, 4x cubed minus 5x over x. I'm going to factor out an x, and we get the limit as x approaches 0. I'm going to factor out an x here to get rid of the denominator. So I get 4x squared minus 5. These cancel. When you plug in the 0, you'll get negative 5. So I plug in over here, I'll do it over here. 4 times 0 squared minus 5, that equals negative 5. So our limit is negative 5. Okay, and I have this one, a little harder if you watched the whole video. So we're going to do the limit as x approaches 1 of f of x minus f of 1 over x minus 1, which equals the limit as x approaches 1 of 1 over x minus 1 over x minus 1. Now I'm going to have take the common denominator here. So I'm going to get the limit as x approaches 1 of 1 minus x over x minus 1. Now, what I'm going to do here is multiply. I'm going to bring down the x here, so I'm going to do limit of x approaches 1. I'm going to bring this x down here. So I'm going to get x times x minus 1. And I can multiply the numerator by -1 and flip this. So we're going to get x minus 1. Okay, basically you can do that. So what we get is these cancel, and when you plug in 1, -1 over 1, and that's going to equal -1. Okay? And the last one, we're going to kind of do the same thing. We can have the limit as x approaches 1 of f of x minus f of 1 over x minus 1, which equals the limit as x approaches 1 for 1 over x squared minus 1 over x minus 1. Again, I'm going to clean the numerator up. That's 1 minus x squared, just having the same common denominator over x minus 1. I'm going to bring him down. I'm going to move this over here a little bit. So I'm going to do the limit as x approaches 1. I'm going to put the -1 here and write this as x squared minus 1. And I'm bringing him down to the denominator here. Should have learned that in pre-cal. And we know that this can be factored, so we have limit as x approaches 1, negative x minus 1 times x plus 1 over x squared times x minus 1. This cancels. Now plug in the 1, and we're going to get -1 plus 1 over 1, which is going to yield -2. That's a parentheses. -2. And that's all of that. Pretty simple little algebra tricks here, and that is all.